Hey, Marion. So here are those three problems that you asked for. It was for numbers 5, 8, and 9 on page 297. So we're going to go through these. These are actually fairly quick problems. So we're supposed to simplify each radical. Okay, in number 5, all right, we have two binomials, right? And when we have two binomials multiplied together, right, we have these parentheses times that parentheses. What we can do is we can use our FOIL method. All right, we just need to multiply these two together. So when we're multiplying two radicals together, so we're going to use FOIL. Let's write that over here, FOIL. Right, it's first, outside, inside, and last. So we're going to multiply the first, all right, that's our F. So that is 3 times the square root of 2 times 4 times the square root of 5. And when we multiply radicals, we multiply the coefficients first. So we have 3 times 4, that's 12. And then we multiply the radicals. So square root of 2 times the square root of 5 is the square root of 10. Okay? So that's how we multiply radicals together. So square root of 3 times the square root of 2 times 4 times the square root of 5 is 12 times the square root of 10. So this whole thing equals 12 times the square root of 10. And then we do the outsides, right? 3 times the square root of 2 times the positive square root of 2. Well, we do the coefficients first, and this is an invisible one, so 3 times 1 is 3, and this is positive because I have a positive times a positive. So positive 3, and then what is the square root of 2 times the square root of 2? Well, that's the square root of 4, and what's the square root of 4? Well, that's 2. So it's 3 times 2, and we know that the 3 times 2 equals what? Equals 6. All right, so I'm just going to write this as 6. Then we do the insides. These guys right here. So that was outside, this is inside. So negative 5 times the square root of 5 times positive 4 times the square root of 5. Well, what is negative 5 times positive 4? You do the coefficients first. Well, that's negative 20 times the square root of 5 times the square root of 5. Well, that's the square root of 25. And what's the square root of 25? It's 5. So that would be 20 times 5. And what's 20 times 5? Well, that's 100. So that's negative 100. And then we do the last. And that's negative 5 times the square root of 5 times positive square root of 2. So I've got negative 5 times positive 1. That is negative 5. And then I have square root of 5 times square root of 2. Well, that's square root of 10. Okay? So we just FOILed this, these two binomials, we FOILed them. So now we have this. And now we can add our common terms, or like terms. Well, we could certainly add these guys together because they have the exact same radical. Okay? So when you have 12 times the square root of 10 minus 5 square root of 10, then that is just 12 minus 5, so that'd be 7 times square root of 10. All right? And then positive 6 minus 100 is negative 94. So this is your answer. This right here, these two binomials multiplied together with radicals in them, simplified is 7 times the square root of 10 minus 94. Right? Because after we FOILed it, we just combined our like terms. So we combined our square roots of 10 together, and then we combined our coefficients together. And that's what we get. All right? Okay, let's look at number 8. Number 8 says 7 over the square root of 14. Well, we can't have a square root in our denominator, so we have to rationalize our denominator. I think that was in section 8.5, I think. So to rationalize a denominator, we've got to get the square root out of the denominator. So how do we do that? Well, we multiply by 1, okay? But we're going to use square root of 14 over the square root of 14. Because the square root of 14 over the square root of 14 equals 1. All right? So I'm multiplying this by 1, but we're going to use square root of 14 over square root of 14 because if I multiply the square root of 14 times the square root of 14, what do I get? I get 14. Okay? So this will equal 7 times the square root of 14 over square root of 14 times square root of 14 is 14. All right? Now, does 7 go into 14? Yeah, it sure does. How many times? Twice. So that will equal square root of 14 over 2. And that is your answer. Square root of 14 over 2 is 7 over the square root of 14 simplified. Okay? We have to get that radical out of the denominator. Okay? So that's how you do number 8. And I believe number 9 is very similar to that. So let's do number 9. Number 9 is the square root of y cubed over 5y. All right? So what we can do with this is we can rewrite this as, if I have got the square root of this fraction, then that means the square root of the numerator over the square root of the denominator. All right? So that's how we can rewrite this. And remember, we cannot have a radical in the denominator. So we're going to multiply this fraction by 1. And in order to have 1, we are going to multiply it by square root of 5y over the square root of 5y. And that's going to get this radical out of the denominator. So if we multiply that, what we get is the square root of y cubed times the square root of 5y all over 5y. Because the square root of 5y times the square root of 5y equals 5y. All right? Now I'm going to rewrite this over here. So now I've got the square root of y cubed times the square root of 5y. And that is all over 5y. So now I'm going to multiply these two together. So what do I get? I get the square root of 5y to the 4th. 5y to the 4th. Because when we multiply exponents, we add the exponents together. And this is just an invisible 1. So 3 and 1 equals 4. And that's going to be all over 5y. Now, can we get a square root of 5? No, I can't get an even number out of it. But can I take this, this y to the 4th out of the radical? Oh, I sure can, because the square root of y to the 4th, what's the square root of y to the 4th? Well, we know that that equals y to the 4 over 2 because the index is 2, right? So that equals y squared. So I can take that y squared out. That's going to equal y squared times the square root of 5 over 5y. Well, can I simplify it anymore? I sure can, because I've got a y here and I've got a y squared here. So I can take that y out and this just turns into a 1. So now the final answer would be y times the square root of 5 over 5. And that is your simplified answer of this radical. Okay? So the square root of y cubed over 5y is the same thing as y times the square root of 5 over 5. Okay? And that's the progression. All right? We have to understand that we have to rationalize our denominator. So when we rationalize our denominator, we multiply by 1, which is the denominator over the denominator. Multiply that out. And then if we have two radicals, we can multiply those two radicals together to get a square root of 5 times y to the 4th over 5y. And then we can take out the perfect squares that are inside the radical. Well, the perfect square would be y squared, right? Because y to the 4th, the square root of y to the 4th, we just showed over here, is y squared. So I pull y squared out. And then I can cancel this y, and that's how I come up with that. Okay? I hope that makes sense. Review that, look over it, make sure you understand it. If you have more questions, let me know. All right? Take care.